Hello. Now, continuing with our linear and quadratic equations in context, we're going to look at our question here about right angle triangles, and it's critical anytime they mention a shape or anything that we can draw at all. We're always going to draw a sketch every time, and it doesn't have to be with rulers and with terribly accurate drawing, but if we can get a sketch that allows us to picture what they're saying in the question, it makes it vastly more likely that we're going to be able to make progress. So anytime we can in maths, universally, we'll draw a picture if we can. Having said that, let's get into our question. In a right angle triangle, a side is 2 units shorter than the hypotenuse, and the third side is 1/6 the length of the perimeter. Find the length of the hypotenuse. There's a lot of words going on here. So what I'm going to do is try and anchor this for myself by drawing the thing that I'm very clear is in the question. There's a right angle triangle. So let's draw that. I've got a right angle triangle. You can see there's nothing fancy about this drawing. A right angle triangle. And I'm told a side is 2 units shorter than the hypotenuse. So let's call the hypotenuse x, because I'm told something relative to the hypotenuse, so let's call it x. And a side of my triangle, I could pick either of these, is going to be 2 units shorter. So if x is the hypotenuse, then my side that I'm describing there is going to be 2 units shorter. And the third side, so the side that's left, is going to be 1/6 the length of the perimeter. Okay, let's call the perimeter P. P for perimeter, and this is going to be 1/6 of the perimeter. For me anyway, that is a lot easier to understand now. I have an awful lot more information available to me now that I've written it in that form, and I'm looking for the hypotenuse that I've called x. So I'm looking for x. So what is x equal to? I don't know how to solve this problem yet, but I can write down any equations that I can think of that I know from right angle triangles. So what have I got here? I know that I'm dealing with the perimeter. So the perimeter, I'm told I'm dealing with the perimeter in the question, so let's write that down. What would be the perimeter of this shape? Well, it would be the perimeter, capital P, is going to be equal to the sum of my sides. That's what the perimeter is. If I go this length plus this length plus this length, I must get the perimeter. So x plus x minus 2 plus the perimeter divided by 6 must add up to the perimeter. That's one equation that I've now got, and I can tidy that up in a minute. What's another thing that I know? I'm told specifically I'm dealing with a right angle triangle, and I'm told I'm dealing with the hypotenuse. Now these are keywords that tip me off to what I'm likely to have to deal with. I'm thinking I'm going to have to deal with Pythagoras. So hypotenuse squared is equal to the sum of the other two sides squared, and that is what I'm going to try and write down. So I've got x squared is going to be equal to x minus 2 to be squared plus p over 6 to be squared. Now again, I'm not sure of how I'm going to solve the problem yet. What I'm doing is drawing a picture and writing down information that I can think of. I could also write down stuff about sine, cos, and tan, but because there's no mention of angles here at all, I'm going to try and do what I can with these, and if I run into a problem, I might try writing down what I know about sine, cos, and tan for our triangle and see if that can help me. But for right now, I've got two equations, and I'm going to try and tidy them up and see if I can make progress based on them. So let's break this up. I have my equation here. I've got a fraction, and I never like fractions. So what I'm going to do is add my like terms up together. So p is equal to 2x minus 2 plus p over 6. I'm going to multiply both sides of my equation by 6, which is my lowest common denominator. So my lowest common denominator is going to be 6. And I'm just going to multiply everything by 6. This is a fairly simple situation, so I should be able to get away with just multiplying everything by 6 and avoiding having to do my more complicated way of getting rid of fractions, which would be to get everything over the common denominator and then multiply by 6. This is fairly simple, so I'm relatively unlikely to make a mistake. So I'm happy to just do this out. So minus 12 plus p. So if I subtract p from one side, so I have all of the p's together, I end up with 5p is equal to 12x minus 12. So that's one equation. I've made that neatened up. Now, I'm not sure what to do with that yet, but I'm going to square this out now and see if I can get anything else that's going to work for me. So this is my second equation. So we'll call that equation 1. And I square this out now, and I get x squared is equal to square the first by the second and double it, square the second, plus p squared all over 36. Again, I have a fraction here, which I don't like. I also have x squareds on both sides, so they're going to sum to 0. So I'm going to get at minus x squared minus x squared. And I'm going to end up with 0 is equal to minus 4x plus 4 plus p squared all over 36. And I don't like this fraction, so I'm going to multiply both sides by 36 so that I'm dealing with numbers that don't involve fractions, because pretty universally fractions are a nuisance. Again, because this is a relatively simple situation, I'm not too worried about having to get everything over a common denominator of 36 first. Though if you feel more comfortable with that, that is perfectly fine. Now when I multiply 4 by 36, I'm going to get at 144 plus 144 plus p squared. Now I'm going to isolate the p squared by itself because I just want to have the variables separated out a little bit. So if I get the x's on the left hand side, so plus 144x minus 144. If I do that out, I get p squared is equal to 144x minus 144. Now I've tidied up both of the equations that I was able to figure out. And can I see anything that I can do with them? Well, now that I've tidied this up, something does jump out at me. I have something that's quadratic here, and I have something that's linear here. So I have ended up with something that is a linear and a quadratic simultaneous equation. I have two equations. One of them is quadratic and one of them is linear. So I'm just going to do simultaneous equations and see if I can find the value of p or x. And because the x isn't squared here, I think the maths is going to be easier if I take equation 1 and rearrange it to have x equals something involving p. I think that's going to make my life easier. So that's what I'm going to do. So I'm going to take equation 1 and I'm going to rearrange it. So I have 5p is equal to 12x minus 12. And I'm going to rearrange that so that I can sub it in for the x in here. So I'm going to get x by itself and sub it in. So remember how we solve our linear and quadratic equations. So I have plus 12 on both sides. I get 5p plus 12 is equal to 12x. Divide both sides by 12 to get x by itself, so that I can sub it into my quadratic equation. I get 5p plus 12 all over 12 is equal to x. Now I'm going to sub this in to my quadratic equation. So I end up with p squared is equal to 144 on 5p plus 12 all over 12 minus 144. P squared is equal to, I have divided by 12 here, so when I multiply out my pieces here, 12 divided by, into 12 here will leave me with 12 on 5p plus 12 minus 144. P squared is equal to 60p plus 144 minus 144. My 144s, both numbers here sum to 0, so I'm left with p squared is equal to 60p. I recognize I've got a quadratic, so I'm going to rearrange to have all of my terms on the same side. P squared minus 60p is equal to 0. I recognize I can take out a common factor here. I could theoretically use the minus b formula, but there is no good reason to do so here. So p could be equal to 0, or p could be minus 60 could be equal to 0. P would be equal to 60. I discard this answer because it would give me one of my, well, it would give me something that it doesn't really make any sense. I would end up with a negative length, and I would end up with a I would end up with the situation not making any physical sense. I can't add a bunch of real lengths up and get 0. So this must be my actual solution. So going back into my linear equation, I would end up, where did I have a nice version of my straight line? I will just sub into my straight line equation, so I would end up with 5 on 60 is equal to 12x minus 12. So I end up with 300 is equal to 12x minus 12. Rearranging, 12x is equal to 312, dividing both sides by 12. I get x is equal to 26. And units, because it mentions that we're dealing with lengths in this situation. So key takeaway from, and that is my hypotenuse, which is what I was looking for. So that's the job done. Now, the key takeaways here are, this is quite a complicated bit of English, but if I draw a picture of what it describes and then write down any formulas I know, anything that it's mentioning, like the perimeter, like the fact that I've got a hypotenuse and a right angle triangle, so I'm going to try and use Pythagoras. If I draw the picture and write down the equations that I know based on that picture, I will virtually always be able to get the question out. In terms of marking scheme, if I drew the picture and got down my first two equations, I would have at least passed the question. I'd have at least gotten 40%. Often I'd have gotten closer to 50%. So the first step, this being able to draw a picture and then write down any equations that are relevant to it, is a huge skill that we want to have. And it comes from, anytime we can, drawing a quick sketch of the situation described, and over time we build up that skill, and it will be there for us when we need it in the exams. So that is how we approach our word problems, and always try to draw a picture when we can.